On this Silverado 2500 with the 6.6 diesel, P0087 is fuel rail low pressure. In plain terms, the control module is seeing rail pressure that may not be where it needs to be for the operating condition. The truck may run poorly, may be hard to keep running, or may go into a shutdown-type response. Broadly, the fault area can be the rail pressure signal, low side supply, return control, pressure regulators, fuel quality, injector or rail leakage, restriction, or the high-pressure pump. The control module is using sensor feedback and actuator control to manage fuel pressure, and both fuel pressure regulators are part of that pressure control strategy. So this diagnosis is about checking command versus response instead of guessing at parts. For this code, treat the running conditions as the monitor gate. P0087 runs with the engine running, ignition voltage greater than 11 volts, and it runs continuously after the running conditions are met. The setting logic is fuel rail pressure not within a calibrated range for greater than 1 second. That tells you the code is not just a static electrical check. It is a pressure control problem based on what the system is trying to do and what the rail pressure feedback says happened. Start with the basic system checks. Follow a structured diagnostic approach and make sure the general diagnostic procedure basics are covered before going after P0087. Then put the ignition on with the vehicle in service mode. Before testing this code directly, make sure there are no fuel pressure regulator control codes that need to be handled first. After that, check for codes related to the rail pressure sensor, primary fuel pump driver control module, or either fuel pressure regulator control circuit. If those are present, check what they mean first. If they are not present, run the engine at idle and look at the fuel pressure sensor value. The expected idle range is 370 to 450 kPa, that is, 54 to 65 psi. If it is less than 370 kPa, 54 psi, move into low-side fuel system diagnosis. If it is greater than 450 kPa, 65 psi, move into fuel return system diagnosis. If it is between 370 and 450 kPa, 54 and 65 psi, keep going with the P0087 verification path. Once the idle pressure is in that 370 to 450 kPa, 54 to 65 psi window, operate the vehicle under the conditions that run the code. If captured operating data is available from when the fault happened, use those same conditions to try to reproduce it. Then verify whether P0087 sets again. If the code does not reset, the result is all okay at that point. If it does reset, move into the circuit and system testing portion of the diagnosis. For system testing, turn the ignition and vehicle off first. Now check for the conditions that can make rail pressure control look wrong. A poor connection or skewed rail pressure sensor, leaking or restricted injectors, a leaking or restricted fuel rail, contaminated or poor quality fuel, and a leaking or restricted fuel feed pipe. Use the appropriate supporting tests for those areas, such as cylinder balance for injector concerns and leak checks for fuel leakage. If one of those conditions is found, repair it or replace the affected item as necessary. If none of those conditions is found, continue with the active command testing. With no earlier condition found, run the engine at idle. Command fuel pressure control, regulator 1 to increase and decrease, and watch fuel rail pressure sensor 1. The value should change with each command. If it does not change, replace Q18A fuel pressure regulator 1. If it does change, command fuel pressure control, regulator 2 to increase and decrease. Again, fuel rail pressure sensor 1 should change with each command. If it does not change, replace Q18B fuel pressure regulator 2. If both regulator commands produce a pressure response, command fuel rail pressure to increase and decrease, and continue to the desired versus actual pressure check. During this high-pressure side check, note that fuel rail pressure maximum at idle speed is listed as 120 MPa, or 17,405 psi. Now compare desired fuel rail pressure against fuel rail pressure sensor 1. They should be within 2,000 kPa, 290 psi, of each other. If they are not within 2,000 kPa, continue with high-pressure side fuel system diagnosis. If they are within 2,000 kPa, Test or replace the G18 high-pressure fuel pump. After the repair is complete, verify the repair and confirm P0087 stays gone. The takeaway is simple. Prove supply pressure first, reproduce the code, eliminate leaks, restrictions, fuel quality, and sensor concerns. Then use commanded pressure changes to separate regulator response from high-pressure pump capability. For more diagnostic training, visit stepdiagnostics.com.